Welcome, guys, to the new chapter of chemistry, class 12, solutions and colligative properties. This is the chapter of physical chemistry. As we know, we have three parts of our chemistry in class 11th and 12th, that is physical chemistry, inorganic chemistry and organic chemistry. Okay, so I'm starting the chapter. Like in our daily lives, we almost never see pure things. Okay, most of the things are mixtures containing two or more pure substances. Okay, like most things you touch, breathe or eat are combination of different parts. Example, the air. It isn't just one gas, it's a mixture of gases, primarily oxygen, nitrogen and different gases. Okay, our water, it isn't just H2O, it has tiny amounts of minerals and salts dissolved in it. Our blood, it's a mixture of different components, alloys such as brass, bronze, stainless steel, etc. are also mixtures. In this chapter, we will consider mostly liquid solutions and their properties. So, what is the definition of solution? A solution is a homogeneous mixture of two or more than two components. Okay, first learn what is a homogeneous mixture. Okay, a homogeneous mixture is a solid, liquid or gas that contains two or more substances blended so perfectly that they look like just one thing. Okay, in short, it is uniform. Like every sip or scoop is exactly the same as the next. Okay, normality, that is 0.5 molarity H2SO4 solution is given, find its normality. So, and factor of H2SO4 will be 2 because of the H plus ions. So solution will be, we know that normality equals to polarity into Z factor. Okay, so polarity is 0.5 into N factor or Z factor is 2, so 0.5 into 2 is 1 normality, and the rest of the part we will cover in lecture 2. Okay, thank you. The classification. Solutions which contain two components in it are called binary solutions. A binary solution is just a mixture made up of exactly two things. Bi means two. It's very common. Okay. Substances which are used to prepare a solution are called components. Okay. They are also divided into two roles, the solvent and the solute. First, understand what a solvent is. The component that is present in the largest quantity is known as solvent. Okay, in a solution, the component that is present in the largest quantity is known as solvent. Solvent determines the physical state which solution exists. It decides if the final result is a solid, liquid or gas. In sugar water, the water is the solvent. Okay. The another thing is solute. The other component present in lesser quantity is known as solute. Okay. Each component may be solid, liquid or in gaseous state. Is a simple breakdown of some important relationships. First is dilution law. think of this like making orange juice from a concentrate. Okay. When you add water, which is the solvent, the total amount of the juice concentrate, which is the solute, stays the same, even though the total volume increases and the taste gets weaker. Because the amount of solute doesn't change, we use this formula. For molarity, it will be m1 into v1 equals to m2 into v2, and for normality it will be n1 into v1 into equals to n2 into v2. Okay, it means starting concentration into starting value equals to ending concentration into ending value. Let's talk about molarity and normality. These two terms both measure how strong a solution is, but they could count different things. Molarity counts the whole molecule and normality counts the active parts of the molecule, like H plus ions in an acid and OH minus ions in a base. The relationship is normality equals to Z into molarity. Z factor is the multiplier. For example, if one molecule of sulfuric acid releases 2 hydrogen ions, then Z equals to 2. In that case, normality would be double the molarity. Our last concentration term, which is normality. At first, we have to know what is the Z. Z is actually valency factor, which acts as the power or active parts of a molecule. For an acid, it's how many H plus ions it can give away, and for an base, it's how many OH minus ions it can give away. Okay, let's talk what is equivalent weight. Okay, this is the weight of a substance that provides exactly one active part. You have to find it by taking the total weight of the molecule m divided by power z. Okay, and what is number of equivalent? This tells you how many active units you actually have in your sample. It is like counting moles but adjusted for the chemical strengths, and its formula is number of equivalents equals to weight by equivalent weight. Okay, and the last, let's talk about normality. It is a way to describe how strong a liquid is. It tells you how many of those active units equivalents are swimming in 1 liter of the liquid, and its formula is normality is equals to number of equivalents of solute divided by volume of solution in liter. On the topic molarity, where 4 gram of NaOH is dissolved to make 500 ml of solution. Find molarity. Okay, and here the molar mass is given 440 gram per mole. Okay, so we have to find moles first. So moles of NaOH equals to given mass, which is 4, and divided by molar mass, which is 40. So moles of NaOH will be 0.11. Let's convert the volume 500 milliliter to liters, which will be 0.5 liter. So let's find molarity. M equals to number of moles of solute, which is 0.1 mole divided by volume in liters, which is 0.5, equals to, if we calculate this, it will be 0.2 m. Okay, move to our seventh concentration term, which is molality. Molality is a measure of the concentration of a solute in a solution. It is defined as the number of moles of solute per kg of solvent. It represents moles of solute present per kg of solvent, and its formula is moles of solute divided by mass of solvent in kg. In molarity, it is volume of solution in liters, and in molality it's mass of solvent in kg. Don't confuse this. Okay, so the units are mole per kg, which is also represented by small m or molar. Molality, where 10 gram of ura is dissolved in 90 gram water, find molality. The molar mass of ura is given 60 gram per mole. Let's solve this. We have to find the moles of ura. Mass of solvent in kg. Let's convert this, and we have to find the molarity. Equals to 0.167 divided by 0.09, which is 1.85. Okay, let's move on the next concentration term, molarity. So molarity is a way to measure the concentration of a solution. It tells you how much solute is dissolved in a specific amount of solution. Okay, the rule is, it is the number of moles of solute found in 1 liter of solution, and its formula is moles of solute divided by volume of solution in liters. Okay, so unit of molarity are mole per liter, also represented by capital M or molar, and density of a solution is mass of the solution per unit volume. Here it is given. This is actually, this. Okay, to our fifth concentration term, which is mole fraction. It is a word to express the concentration of a substance in a mixture. Think of it as looking at a share one ingredient has in a total recipe, but counting by particles, which is moles, instead of weight or volume. In simple terms, it tells you out of every 1 mole of the total mixture, how much of it is specifically substance A. So it represents moles of a solute present in 1 mole of solution, and its formula is mole fraction equals to number of moles of the component divided by total number of moles in all the components. Okay, for example, in a binary mixture, if the number of moles of A and B are in A and in B respectively, the mole fraction of A will be, this letter is chi A is Na divided by Na plus Lb, and if it is star B, it will be Nb divided by Na plus Nb. On the topic mole fraction, where it has been asked 10 gram of NaCl is dissolved in 90 gram of water, find mole fraction of NaCl. So you have to find the mass of NaCl which is NS molar mass is 23.5 and chlorine's molar mass is 35. So 35 plus 23.5, which is 58.5 per mole, and we have to also find molar mass of water, which is T plus 16, 18 gram per mole. So now moles of NaCl, which is given mass 10 gram divided by molar mass, which is 58.5, which is approximately 0.171. And now we have to find moles of water, which is actual mass is given 90 gram divided by molar mass, which is 18 gram, and moles of water is 5. So now total moles 5 plus 0.171, which is 5.171. So let's find mole fraction of NaCl, which is 5 NaCl equals to 0.171 divided by 5.171, which is approximately 0.033. It is your answer. Question term is parts per million, which is ppm. This unit is used when a solute is present in very tiny amounts, such as pollutants in air or minerals in water. So it tells you how many units of a substance are present for every 1 million units of the total solution, and its formula is parts per million ppm, which is number of parts of the component divided by total number of all the components of solution into 10 to the power 6. Okay, think of it like a percentage, but instead of multiplying by 100, you multiply by 1 million, where it has been asked 0.0025 gram of solute in 500 gram solution and ppm. So we know ppm is number of parts of the component divided by total number of all components of solution into 10 to the power 6. So ppm is equal to number of parts of the component, which is 0.0025 divided by total number of all components of solution, which is 500, into 10 to the power 6, which is so let's solve it. 0.0025 is actually 1 by 400 and 500 into cancel the zeros. So the answer is 5. Move to our second concentration term, which is volume percentage. This represents the volume of a component in 100 ml of a solution. Okay, and formula for this is volume percentage of a component is volume of a component divided by total volume of a solution into 100. This problem asks to find the volume percentage of alcohol in a mixture where 20 ml of alcohol is mixed with 80 ml of water. Okay, so this is solvent, this is solute, and volume of solute is 20 ml. Volume of solvent is 80 ml. Total volume is 20 plus 80, 100 ml, and the mass percentage formula, volume percentage formula is volume percentage equals to, let's see, volume of a component and total volume of solution. So volume of a component, actually a solid component, 20 ml, and total volume is 100 into 100, cancel 20%. Third concentration term, which is mass by volume percentage. It's a way to describe the concentration of a solution. In simple terms, it tells you how many grams of solid are dissolved in every 100 ml of liquid, where mass is the weight of the substance you are dissolving, which is actually the solute, which is measured in grams, and the volume is the total amount of the final mixture, which is the solution, it is measured in milliliters. And the formula is mass by volume percentage is mass of solute in grams by volume of solution in ml into 100. The question is, if 5 gram of salt is dissolved in 100 ml of water, find mass by volume percentage. To find the mass by volume percentage, you just need to see how much salt, which is solute, is in 100 ml of water, which is solvent. So mass by volume percentage equals to mass of solute by volume of solution in ml, and mass of solute will be in grams into 100. So here mass of solute is 5 gram and volume of solution in ml 100 ml of water, so 100 into 100, which is 100 cancel 5%. And the last is solid is the solvent. And if we take gas as a solute, the example is solution of hydrogen in palladium. Okay, it is actually a industrial catalyst. Okay, and if we take liquid as a solute, the example is amalgam of mercury with sodium. Okay, if we take solid as a solute, the example is copper dissolved in gold. It is metal alloys. Of solutions, the amount of solute dissolved per unit solution or solvent is called the strength of the solution. It is measured using various concentration terms. First, we have mass percentage. Mass percentage represents mass of a component which is solute present in 100 gram of solution, and its formula is mass percentage of a component is mass of component in the solution divided by total mass of solution into 100. A question of mass percentage where it has been asked 20 gram of solution is dissolved in 80 gram water. Find the mass percentage of sugar. So the mass of solute is actually sugar, which is 20 gram, and mass of solvent, which is present in major amount water, is 80 gram. What the total mass of the solution is 20 gram plus 80 gram is 100 gram. So the formula for mass percentage is mass percentage equals to mass of sugar the total mass of solution by into 100. So mass of sugar is 20, total mass of solution is 100 and into 100. So 100 cancel. Mass percentage is 20%. Second part, liquid solutions, where we take the solvent is liquid, and if we take gas as a solute, the primary example is oxygen dissolved in water. If we take liquid as a solute, the example ethanol dissolved in water. Okay, and solid is a solute, then the example is glucose dissolved in water. Okay, this table illustrates the different types of solution based on the components. Okay, in a solution, the solvent is the substance present in the major amount and it determines the state of solution, while the solute is the substance being dissolved in it. First, talk about gaseous solutions. Okay, if we take gas as a solvent and gas also as a solute, the primary example is mixture of oxygen and nitrogen gases. If we take gas as the solvent and liquid as the solute, the primary example is chloroform mixed with nitrogen gas. If we take gas as a solvent and solid as a solute, the primary example is camphor in nitrogen gas.